machine in general. The two biggies here are multi-method dispatch or signature-based dispatch, where you have multiple functions of the same name distinguished only by their argument types. And at runtime, you inspect the types of the arguments and dispatch to the appropriate subroutine or method. Especially in a multi-language system, unless this is supported by the system's base dispatch mechanism, you're not going to get it everywhere. And if you don't have it everywhere, obviously it becomes significantly less useful. You know, if you have a set of code that is counting on being able to do signature-based dispatching, and you have a chunk of your code that doesn't do it, you got a problem. So to do it, you need to wedge into the low-level VM's dispatch mechanism to make it work. And yes, there is price involved. But, you know, if you need it, you pay it, and life is reasonably good-ish. The second thing, which actually to some extent ties back into the multi-method dispatch system, is quantum indeterminacy. In a case where you have one or more objects which have one or more potential states, and you're not entirely sure what state the object actually has, or potentially it has all the states at once. And this is odd enough that I have a slide here, and I bring this up because, yes, I have to support this. Basically, you've got a variable with multiple coincident states, and the actions that you perform on those variables, you perform on all the states at once. And the results that you get back in a case where you're acting on a variable with multiple states, the result has multiple states. As a little example here, assume I have a subroutine foo, which takes a single parameter named, you know, interestingly enough, param, foo, and it returns basically its input parameter multiplied by 4. If I have a chunk of code that defines a variable A that has a state 3, 5, and 7 simultaneously, and then I make a function called foo, and I pass in this variable with multiple states, what I need to do, and what I really need to do, is decompose that variable into its individual states, make that function call multiple times, once for each state, take back all the results, and the resulting value is a superposition of all the values from all the possible function calls. Yeah, this is fun. And then you've got, to make any sort of use of this, you need to have, you need to add any and all operators that let you test a condition where if it's true for any of the states of the variable or all the states of the variable. In this case, I say if any of the values of B are greater than 18, I print yes. And in this case, I would in fact print yes. I saw two hands, you were first, go for it.
So you're going to tell us when you might need to do something?
Yeah,
where you might need to do something like this? Well, as a VM implementer, I need to do it because at least one of the languages running on top of me says this is part of my basic language specification.
Which one?
Perl 6.
Perl 6 allows this?
Perl 6 allows this. They call them junctions. Now, there's actually a Perl 5 module called quantum superpositions that does this for you in Perl 5. And the scary thing is people have it out in production. It turns out to be very useful in the case of system monitoring tools, where, for example, you have a variable, you have an object that represents the state of all the active machines in your cluster, and you want to be notified if any of those machines go down, or you want to be notified if, say, 3 or more of those machines go down, or all you really care is are all the machines up or none of the machines up. And it's one of those things I smile and nod and back away, but nonetheless, it needs to be supported. But yes. Well, actually, let's skip.
So this feeds into a broader question I have, which is, you know, so there's lots of things you can support.
Absolutely.
And I think it's true. You know, and you can look at the different VMs, you know, in terms of what they choose to support. I guess the question in my mind is, you know, how do you draw the line between the things that you're willing to support and things you're not? I mean, what's the criteria that gets applied?
It's a very good question. How do you draw the line? And my opinion is that's somebody else's problem. As a virtual machine implementer, my job basically is to say, okay, what are the specifications you have? What do I need to do to make it work? What are the features that I need to pull in at the low level to get your design, regardless of how crack-fueled it might be, to actually function? So the short answer is I pass the buck, and I leave that to language designers, which works for me. Anyone else? I think I've got like 12 seconds. Yes?
I just want to point out to the skeptics that this is an extremely powerful thing to be able to do if you have vector hardware in the machine. Because those alternative 357 may just be 3 elements in a vector, and then there is implicit parallelism in this, and the any operation is vital to making this usable.
Oh, cool. There's actually like real-world use for this stuff? I always like when that happens. Something I do actually has some real world benefits. And the final 12 seconds here, the other thing you can do within virtual machines that you really need to have support for, things like lazy evaluation. I get back a value, but I don't actually evaluate the value until I call it. And yes, you can sort of get away with this with object systems, but you really want to have some sort of wedge in. Things like active data that actually takes place. You do a load or restore, a method actually gets called. It's not, the data is not considered a passive thing. It can it can put code in between the load and store to actually do something. Proper operator overloading. If you want to do it right, you really need to have VM support. You really hate to call into code that doesn't do operator overloading right. Then things don't work right. It's got to be the same everywhere. And the final one, I just add a little bit, dynamic type changing, which actually is something I also need to deal with. Objects that at runtime change their type. Which is always a fun one. If you don't really have engine support for that sort of stuff, it's kind of an issue, and you certainly need to know that it's going to happen when you build the engine in the first place, because then things like type pointers no longer work, which kind of really sucks, because you would otherwise need to update every single pointer to the object with the new type information whenever the type changes, and that's no fun. So,
How many more slides you got?
I have no idea. Oh, I think this might be the last one. One-time reconfigurability. The one other thing that you obviously would really need VM support is if the VM is going to reconfigure itself at runtime, you really actually need VM support for this. It's very difficult to, in a system that does not support redefining or loading new basic, VM operations at runtime to actually load new basic VM operations at runtime. So if you want to add in, basically, if you want to load in PAL code, or load in new microcode to your VM. If your VM doesn't support it, you can't do that. But it's actually a very powerful feature for extending VMs, because it means that you can define a new set of basic operations, especially if you allow some sort of scoping rules, so they're only enforced in particular subroutines. If you have a language, say Prolog, that for some reason really, really, really wants a couple of very low-level operations, but you only use them in the Prolog code, what you can actually do is have the Prolog compiler emit code that says, I require this library, here are the opcodes from this library, here are the numbers they map in for, and whenever you call any of my subroutines, I tag all my subroutines as needing these opcodes, and basically you have on a per subroutine basis custom assembly language or custom machine language available to you, which is a very powerful feature. Also, being able to change existing functions for existing opcodes at runtime is, again, a very powerful feature. Not something you normally want to do. Well, all this stuff, you're like, I really want layers of security between me and the users who are going to do nasty things, but if you want to at runtime layer in debugging or monitoring facilities, if for some reason you actually need to change the behavior of a particular function or basic operation of the VM, for example, you decide you really can get away with stack-based allocation of activation frames until someone takes a continuation, in which case you switch over to plan B. What you might want to do is the first time someone takes a continuation, you basically change the functions that are called for calling and returning from subroutines. Or in our case, where you're in a continuation passing system for all calls anyway, it's kind of irrelevant. But there are other cases where you have the fast method in until someone goes slow, and then you switch the slow function in, which obviously screws JITs up. But that's where you have either dynamic recompilation of existing code, or you say, wouldn't it be nice to have a JIT? Or you don't JIT those particular functions, and that's also an option too. But anyway, I think I'm done. Yes, I'm done. Cool. I think we have minus 5 minutes for questions.
So let's see. So you pushed off the sort of what should be in the VM to the designer. But I think one of the things about their implementation is that you feed back to the designer, you can have this, but it's going to cost you X. It's sort of like a constraint on your design. So let me just finish the thought. So the question then becomes, it seems like you're very accommodating in terms of saying, we can do all this stuff. It's not that big a deal, right? Mm-hmm. So the real question is, if we can do it, what's the constraint? Who puts constraints on the design? And where is the person that comes in and says, that's just not a good idea?
It's been my experience that the only person that puts a constraint on the design is usually the designer's spouse. Because that's the only person in a position to effectively wield the baseball bat. I find flowers and chocolate work well, regardless of the gender of the spouse. So, and to some extent, for some of this, I will admit, a lot of the features, if you look at it, you go, well, if I have feature 7, I get features 1 through 6 for free. If I have continuations, I get a lot of the rest of the control flow stuff for free. So it's one of those, once you make the decision, it's like, what do you need? Or in our case, what was your base functionality even before they started adding all the new stuff for Purple 6? What's your base functionality? What do I need to support? It's like, well, you've specified that your language does continuations. Well, I need continuation support, and if I just bite the bullet and do it right, then I get the rest of the stuff. I might as well expose the rest of the stuff because it's free anyway. Or you've already, it's not free, you've already paid for it, so. Yeah, and it's a good idea to continue to at least take a look at all the things that you would have to provide as a VM designer or an implementer, and be able to say, okay, if you want this, it's going to cost that, and you decide whether it's worth it or not. And if you're like me in a position to actually say, well, I can do it because the design's not fixed. I don't have 10 years worth of installed base in a fixed bytecode definition. You can at least decide whether it's right or not. So.
How long does it take actually to define what those